Let's get back to the question which we got stuck in the last set of videos. So what was it about? It was about a paper rocket being launched. So let's have a look at that again. So what is that we are looking at? We looked at a 16-gram paper rocket being launched to a height of 12.5 meters. So now the question is quite simple. Ignoring the drag force, calculate the potential energy and what is the initial velocity of the paper and the maximum kinetic energy and so on and so forth. So let's do this using mechanical energy, the idea of mechanical energy. So first thing first, we'll write the given. We have an object from a particular place. I launched it and it reached a particular height. Right. So here what happens? At this height, the maximum, that is the velocity, will be 0. I can call this as final velocity, 0 meter per second. Acceleration due to gravity is your 10 meter per second square. Then the mass of this object is 16 grams, so 16 by 1000 kg. Then what else? The height turns out to be not 16, sorry, 12.5 meters. So basically this is 125 by 10 meters. Okay, so this is your entire setup. Right. Now let's figure out the potential energy of the paper rocket at its highest point. So we have the working. So we have a particular case. So what is the case? We are looking at potential energy at top. So how do we go about doing this? Potential energy is equal to mgh. All you have to do is substitute 116 by 1000 into 10 into the height. So we have a set of zeros that we can cancel. And again, I spoke to you guys about this. I'll multiply and divide with 2 because 125 into 2 is, we have, what is that? 250. 250 dividing 1000 is 4. 4 2s are 8. And all of this gets cancelled and all of this will be equal to 2 joules. So, okay, let me write it over in the next slide itself. Yeah. So potential energy is equal to 2 joules. Right. Next question is, what is its initial velocity of the paper rocket when launched? See, it's quite simple. When I'm launching, we are taking that there's no drag force, nothing happened. All of the energy gets converted to kinetic energy, potential energy at the top. Means what? The kinetic energy, whatever was there initially, got converted to potential energy. So basically, even the kinetic energy will have the same energy initially when it's launched. So kinetic energy is equal to 2 joules. Since we know the kinetic energy, we can deal with, yes, finding the velocity. So let me talk about this case. Initial velocity, right? So basically at the bottom, is it not? At bottom, that's what we mean. Now, how do we go about talking about this? So first we will tell that mechanical energy is constant throughout the journey, right? So therefore potential energy at the top plus kinetic energy at the top will be equal to potential energy at the bottom plus kinetic energy at the bottom. Okay, right? Because all of them are equal to mechanical energy. So at the top, potential energy is 2 and the kinetic energy is 0, at the bottom potential energy is 0, while the kinetic energy is what we have to figure out. So basically kinetic energy is equal to 2 joule. Okay guys, so we know the kinetic energy, and thus we're able to find the velocity, so which is equal to half of mv square. So this is equal to 2 divided by 2, mass is 16 by 1000 into v square. So let us transpose and all of that. So we have actually we can cancel 1s are 8s are 1s are 4s are. So v is equal to square root of 1000 by 4, which is square root of 1000 is 10 root of 10 by 2, so 5 root 10, so many meter per second. People who are confused how I got this, so it's for you guys. 1000 can be written as 100 into 10, so square root of 100 into 10 divided by square root of 4, which is 10 root of 10 divided by 2, right? Okay, all of this comes under exponents, that is taught in basics, so you guys have to watch the basics to understand all of this. So learn the basics, because again exponents you have it in your syllabus as well, right? So you need to learn to handle all of this. So 5 root 10, root of 10 is approximately 3.3 ish, so around 15 meter per second. That's a good speed, 16 meter per second, right? So within a second it's moving 16 meters, so that's pretty good. Okay, so we have, what else do we have? Oh yeah, last set. Find the maximum kinetic energy of the paper rocket. Where will the kinetic energy be maximum? At the bottom. We already found it. We just have to explain it. Case maximum kinetic energy. The maximum kinetic energy is observed at the bottom. The maximum kinetic energy is observed at the bottom, and it's equal to, thus it is 2 joules. That's all. Okay, right? So you can pause and have a look at the answer. So practically we saw how much energy will it have, and all of this can be done at your place as well. So with an understanding of the physics also. So it's fun. If you try to understand, if you make use of your understanding to do something, it's always, it can be replicated somewhere else. If not, if you're just doing for the fun of it, it's okay. But again, the understanding always makes things better. You can manipulate things better. You can, you can predict, you can aim, you can get up, you can set things in a manner which will give you the right result. Like if you want to paper rocket to go into a particular place, you can do that with all of these calculations and so on and so forth. Okay, so you guys can pause and have a look at the answer. Again, remember, this is in absence of air.